Hi everyone, welcome back to this video series on Windows Server 2016, a combination of both. These two modes of using failover clustering mentioned earlier can certainly be combined together for an even better and more comprehensive high availability story. Let's let this example speak for itself. You have two Hyper-V servers, each one prepared to run a series of virtual machines. You are using host clustering between these servers. So if one physical box goes down, the other picks up the slack. That in itself is great. But you can use SQL a lot, and you want to make sure that SQL itself is also highly available. You can run two virtual machines, each one a SQL server, and configure application layer failover clustering between these two VMs for the SQL services specifically. This way, if something happens to a single virtual machine, you don't have to fail over to the backup Hyper-V server. Rather, your issue can be resolved by the second SQL node itself by taking over. There was no need for a full-scale Hyper-V takeover by the second physical server, yet you utilized failover clustering in order to make sure that SQL was always online. This is a prime example of clustering on top of clustering, and in thinking along those lines, you can start to get pretty creative with all of the different ways that you can make use of clustering in your network. How does failover work? Once you have configured failover clustering, the multiple nodes remain in constant communication with each other. This way, when one goes down, they are immediately aware and can flip services over to another node to bring them back online. Failover clustering uses the registry to keep track of many per node settings. These identifiers are kept synced across the nodes, and then when one goes down, those necessary settings are blasted around to the other servers, and the next node in the cluster is told to spin up whatever applications, VMs, or workloads were being hosted on the primary box that went offline. There can be a slight delay in services as the components spin up on the new node, but this process is all automated and hands-off, keeping downtime to an absolute minimum. When you need to cut services from one node to another as a planned event, such as for patching or maintenance, there is an even better story here. Through the process known as live migration, you are able to flip responsibilities over to a secondary node with zero downtime. This way, you can take nodes out of the cluster for maintenance or security patching or whatever reason without affecting the users or system uptime in any way. Live migration is particularly useful for Hyper-V clusters, where you will often have the need to manually decide which node your VMs are being hosted on in order to accomplish work on the other node or nodes. Setting up a failover cluster. We're going to take a few minutes to set up a small cluster of servers so that you can see the management tools and places that have to be touched in order to accomplish this. I have now backed out all of the NLB config on my Web 1 and Web 2 servers that we set up earlier, so that they are just simple web servers at the moment, once again, with no redundancy between them. Let's set up our first failover cluster and add both of these servers into that cluster, building the servers. We have two servers already running with Windows Server 2016 installed. Nothing special has been configured on these servers, but I have added the file and storage services role to both of them, because eventually down the road I intend to utilize these use as a cluster of file servers. The key point here is that you should have the servers as nearly identical as possible with the roles already installed that you intend to make use of within the cluster. One other note during the building phase, if possible, it is a general best practice with clustering for member servers belonging to the same cluster to reside within the same OU in Active Directory. The reason for this is twofold. First, it ensures that the same GPOs are being applied to the set of servers in an effort to make their configurations as identical as possible. Second, during the cluster creation, some new objects will be auto-generated and created in AD, and when member servers reside in the same OU, these new objects will be created in that OU as well. It is very common with a running cluster to see all of the relevant objects in AD, which is Active Directory, and be part of the same OU. OU means organizational unit, and for that OU to be dedicated to this cluster. Installing the feature. Now that our servers are online and running, we want to go ahead and install the clustering capabilities on each of them. Failover clustering is a feature inside Windows Server. So open up the Add Roles and Features wizard and add it to all of your cluster nodes. Running the Failover Cluster Manager. As in the case with most roles or features that can be installed in Windows Server 2016, once implemented, you will find a management console for it inside the Tools menu of Server Manager. Looking inside there on Web 1 now, I can see a new listing for Failover Cluster Manager is available for me to click on. I'm going to open that tool and start working on the configuration of my first cluster from this management interface. Running cluster validation. Now that we are inside the Failover Cluster Manager, you will notice a list of tasks available to launch under the management section of the console near the middle of your screen. Before we can configure the cluster itself or add any server nodes to it, we must first validate our hardware configuration. Failover clustering is a pretty complex set of technology, and there are many places where misconfigurations or inconsistencies could set the whole cluster askew. Your intentions behind setting up a cluster are obviously for reliable redundancy, but even a simple mistake in the configuration of your member service could cause problems large enough that a node failure would not result in automated recovery, which defeats the purpose of the cluster in the first place. In order to make sure that all of your T's are crossed and I's dotted, there are some very comprehensive validation checks built into the Failover Cluster Manager, sort of like built-in best practice analyzer. These checks can now be run at any time before the cluster is built or after it has been running in production for many years. In fact, if you ever have to open a support case with Microsoft, it is likely that the first thing they will ask you to do is run the validate configuration tools and allow them to look over the output. In order to start our validation process, go ahead and click on the link called Validate Configuration. We are now launched into a wizard that allows us to select which pieces of cluster technology we would like to validate. Once again, we must put on our Microsoft centralized management theory thinking caps and realize that this wizard doesn't know or care that it is running on one of the member servers, which I intend to be part of the cluster. We must identify each of the server nodes that we want to scan for validation checks. And so in my case, I'm going to tell it that I want to validate the Web 1 and Web 2 servers. The testing options screen allows you to choose the Run Only Tests. I select Radio button and will be able to run only particular validation tests if you so choose. Generally, when setting up a new cluster, you want to run all of the tests so that you can ensure everything measures up correctly. On a production system, however, you may choose to limit the number of tests that run. This is particularly so with respect to tests against storage, as those can actually take the cluster offline temporarily while the tests are being run, and wouldn't want to interfere with your online production services if you are not working within a planned maintenance window. So I'm setting up a brand new cluster. I'm going to let all of the tests run. So I will leave the recommended option, select Run All Tests, and continue. Once the tests have completed, you will see a summary output of the results. You can click on the View Report button in order to see a lot of detail on everything that was run. Keep in mind that there are tiers of pass fail. Green is good, red is bad, but yellow is more likely it will work, but you're not running best practice. For example, I only have one NIC in each of my servers, but the wizard recognizes that to be truly redundant in all aspects. I should have at least two. It'll let this slide and continue to work, but it is warning me that I could make it even better by adding a second NIC to each of my nodes. By the way, if you happen to be logged in as the administrator like I am, you'll be unable to open the validation report because the Edge browser isn't allowed to launch under the admin account. This is a great security check built into Windows Server 2016, and shame on me for doing anything inside the admin account, the administrator account. But hey, this is a test lab. If you find yourself in a position where you cannot view the report for similar reasons, you can find the report stored inside C, Windows Cluster Reports, copy it to your local workstation and open it up from there. Remember, you can rerun the validation process at any time to test your configuration using the Validate Configuration task inside the Failover Cluster Manager. Running the Create Cluster Wizard. The validation phase might take a while if you have multiple results that need fixing before you can proceed, but once your validation checks come back clean, you are finally ready to build out the cluster itself. For this, click on the next action that we have available in our Failover Cluster Manager console, Create Cluster. Once again, we must first specify which servers we want to be part of this new cluster. So I am going to again input my Web 1 and Web 2 servers. After this, we don't have a whole lot of information to input about setting up the cluster, but one very key piece of information comes in the access point for administering the cluster screen. This is where you identify the unique name that will be used by the cluster and shared among the member servers. This is known as a cluster name object CNO, and after completing your cluster configuration, you will see this name show up as an object inside Active Directory. After finishing out the wizard, you can now see the cluster inside the Failover Cluster Manager interface and are able to drill down into more particular functions within that cluster. There are additional actions for things such as configuration role that will be important for setting up the actual function that this cluster is going to perform, and node, which is your spot to include even more member servers into this cluster down the road. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.